Good day, everybody. I have Shekemi in class with me today. She's going to be part of today's lesson. Say hello.
Hello.
Alright. And we're discussing similarity. And we're talking about similarity of shapes and the scale factor. And basically, this discussion dovetails into proportions. We're going to be discussing, it's going to help you when you are working on proportions. But I don't want you to be phased, because I know you've told me quite a lot of times, most of you, you're scared of geometry. But I keep telling you that a lot of what you do in math is something that is it's something you've been doing all along. So Shekemi, I want you to come and look at these pictures and pick out the odd one on each row. Pick out the odd picture on this row. Can you pick this out? No, on this first row. Thank you. Then on this row, and the third one, and on the last one. Yeah. So Shekemi, why do you think this is very obvious? So I'm not going to ask you. But here we have three different rectangles. So why do you think this one is odd compared to the other two?
They are lying flat. This one is standing straight.
Standing upright is oblong. Kind of. Okay. So are you saying if I drew this in this format, you would consider it the same?
I know.
1, 2, 3. Can you pick out the odd one then?
Still think it's the same.
Okay, so why is that?
It's still too thin.
Alright, that's excellent. It's thinner. It's not as broad as the other ones. And why did you pick this?
These are right angle triangles.
Okay.
These are equilateral triangles.
Okay. Then what's wrong with this one? Why is this one different? Why is it odd?
It's kind of like this one. This one is also too thin.
It's not as high as the others, and it's a bit broad. So what I say to you, that a lot of what you're going to do is innate. You already have an idea, you just don't know how to articulate it, you don't know how to put it in words. When you look at two pictures, two images, you usually can be able to tell that there is something different about this one. And what makes two shapes similar is the proportion of the sides. So in this one, we're not even going to bother and intentionally just put something that is so totally different. But in the other three shapes, we have we could say the same shape. We have three rectangles, and yet one stands out because the proportion of the sides is different from the other two. I have another video in which I explained similarity and proportions on PowerPoint, so I think I would upload that for you too as well, so that you can really understand what we're talking about. But for today's class, let's just stick with this. Now, if we actually do take a measure of these shapes, this small one is actually 3 centimeters by 2. This is 6 centimeters by 4, and this is 1 centimeter by 3. Now, without being told, your sixth sense tells you something is different about this. What is actually different, and what we're concerned about when we're talking about similarity, which would be your focus, is the ratio of the sides. So for this small, I'm going to name this one the small, I'm going to name this one the big. So for the small shape, the ratio of the sides is such as this: length over breadth, and this gives you 3/2. For the big shape, you also have length over breadth. Shekemi, are you with me?
Yeah.
Is there anything that is strange right now? Do you understand what I'm saying? So, and if you reduce this to the lowest end, you still get 3/2. However, for this narrow shape, the narrow rectangle, we still have length over breadth and that gives you 1/3. Now you can see that the ratios are different. These two have similar ratios, and that is all there is. That is the core of our definition of similarity. Shikemi, do you understand that?
Yep.
Two shapes
Yes.
are similar when the ratio of the corresponding sides in each figure remains the same. The ratio of the length to the breadth. If you look at this, like you said, these are right angle triangles. It's not just because they are right angle triangles. Let me draw another right angle triangle for you, and I'm sure you will not find them similar. Now this is a right angle. Now if you consider these three, Shikemi, which one is odd? It's still a right angle, right?
Yes, ma'am.
It's still a right angle triangle.
Yes.
However, the proportion of the sides are different. So without putting pen to paper, without calculating it. So moving on to similarity in triangles, we can see, like Shikemi explained to us, that the three right angles, though they are all three right angle triangles, one seems odd, and that was this. And she said this off camera that it looks more like a scaling triangle. So what we're saying basically is that even without being able to explain it, without doing any computations, without doing any measurements, your gut feelings tells you that there's something different, there's something uniquely different about a certain image or a certain shape when compared to others. So that is what we're really saying when we discuss similarity, and it has to do with the proportion. The human mind, your mind, has the capacity to actually check the proportions without doing any computations or calculations. But when we say two triangles are similar, what it means is that the ratio of the sides, again, as we did with the rectangle, the ratio of the sides of the triangle, let me put this as triangle, the ratio of the corresponding sides also remain equal. So you'd find that for two triangles, let's just use, let me quickly sketch this. You find that the ratio A, B, C, X, Y, Z. So the ratio of AB, side AB, to side BC would be equal to the ratio of side XY to side YZ. You would also find out that the angles formed by the sides would be equal. So I have taken the liberty of cutting out the shapes for you so that you can demonstrate that. Look at these two triangles, two different sizes, but they're quite similar. And if you place one on top of the other, you can see that the angles formed are equal, even though the sides, the measurements of the side are different. So we can say they are equal angular. However, let's look at this too. You have a right angle triangle here. We have a square corner on one edge. That's how to test for our square corners very easily. Now you can see that you have square corners here, right? However, even though one of the angles in the triangle, one is equal, the other two angles are not. Look at this. You can see that if you flush this one side, the other one juts out, and on this other side as well, you can see that there's an excess here, which means that these two triangles, though they are both right angle triangles, they are not similar in any way. Now, one thing you need to be very particular about when discussing or when working with similar triangles is the way you name your triangles. Let me use these two triangles again, and then I'll use this. This is A, B, C. This is X, Y, Z. Please note that triangle ABC is similar to triangle X, Y, Z. But it is not similar to triangle Z, X, Y. You must take note of the order of the numbers, because when you name your triangle, it also gives your reader or your audience the idea of the dimensions. When you talk about ABC, it means sides AB. The ratio, the sides AB is proportional to side XY. In this case, it's easy because we are talking about the hypotenuse, right? And then it means sides BC is proportional to side YZ. When you change the order of the name, someone who does not see the picture, anybody who did not see the picture of the triangles, would have a problem comprehending what you're saying, because the dimensions of AB most definitely may not be proportional to the dimension of ZX. Same with this one. Let's say QRS and triangle ABC again. Now, triangle QRS is similar to triangle ABC, and you can see that side QR and side QS are the equal sides, which is also shown here, AB and AC. But if you change the order of the naming, it will give you a completely different information. So that is one thing you need to be mindful of when you are naming your triangles. But at the end of it all, you need to be aware of the qualities of similar shapes. So in the next class, we're just going to move on to try and solve some exercises. See you in the next class.